children. So we will continue with trigonometric ratios part 2 today. In the last class we saw the formulas and some problems. So in the last class also I told you the formulas are very important. You must know those formulas by heart, then only you can do trigonometric problems, okay, proving identities. So let's take some more questions today. Number 1, we have to prove LHS. We take, okay, 1 plus sin A by cos A plus cos A by 1 plus sin A. This is left hand side and we have to prove that this is equal to 2 sec A. So here we cannot use directly formula, okay, because there is no formula for 1 plus sin A. Okay, so what to do, we take LCM. Alright, so let's take LCM. LCM is cos A into 1 plus sin A. This is the LCM. So when the LCM is a product, you can multiply cross here. So 1 plus sin A into 1 plus sin A will be 1 plus sin A and its whole square plus cos A into cos A will be cos square A. Okay. Now you open the bracket in the numerator. Okay, so I'll write it to this side so that we have space on that side. So 1 plus sin A plus whole square. A square is 1 square plus B, 2AB is 2 sin A plus B square is sin square A plus cos square A you have by cos A 1 plus sin A. Remember RHS is 1 plus sin is there, so we keep it as it is. We try to cancel cos A. So is equal to, so 1 plus 2 sin A as it is. Now this sin square A plus cos square, you know it is 1. So we can write 1. So cos A 1 plus sin A as it is. So this will give you, so 1 plus 1 is 2. So if you take 2 common, so we get 1 plus 1 plus sin A by cos A. By cos A. No, see, RHS we have 2 sec A. Okay, 2 sec A. So we have to cancel this 1 plus sin A. Okay, so cos A 1 plus sin A. Okay, because RHS we have 2 sec A. So 1 plus sin A needs to be cancelled. 1 plus sin A cancels. So 2 by cos A. 2 by cos A is 2 sec A, because 1 by cos A is sec A. So it is RHS. Okay, so it can be proved this way. Now let's take question number 2. Question number 2. So we take left hand side. Left hand side equal to, we have tan A by sec A minus 1 plus tan A by sec A plus 1, and what we have to get, 2 cosec A. So right hand side is 2 cosec A. So it's easier to change into sin cos, because 2 cosec is there. Cosec comes from sin, because 1 by sin is cosec. So if you get 2 by sin A, then you get 2 cosec A. So we change into sin cos and simplify, it will be easier. So tan A is sin A upon cos A by sec A is 1 by cos A minus 1 plus sin A by cos A, that's tan A, and sec A is 1 by cos A plus 1 equal to. Okay, so if you take LCM, we get sin A upon cos A by, if you take LCM here, cos A, you get 1 minus cos A plus sin A by cos A upon cos A is the LCM, so 1 plus cos A you get. Okay. So this will give you, this is equal to, so if you change division to multiplication, you get sin A by cos A into, this cos will go up, so cos A by 1 minus cos A you get, you are changing division into multiplication, plus sin A by cos A into, this will 1 second reciprocal, cos A goes up, 1 plus cos A you get. So this will give you, here cos A get cancelled, here also cos A get cancelled, so you get sin A by 1 minus cos A plus sin A by 1 plus cos A. Now you can take LCM, 1 minus cos A into 1 plus cos A. So it will be sin A into 1 plus cos A, because these two will multiply, plus sin A into 1 minus cos A, because these two will multiply. So now open the bracket in the numerator. So you get sin A plus sin A into cos A, sin into cos, plus sin A plus into minus minus sin A into cos A. So denominator as it is 1 minus cos A into, okay, you can here also you can write 1 minus cos A, 1 plus cos A is 1 minus cos square A, using A plus B, A minus B formula. So this will give you, here sin A, cos A being plus minus cancel, sin A plus sin A is 2 sin A, and 1 minus cos square is sin square A. So sin A and square get cancelled, so you get 2 by sin A, and that is 2 cosec A, and that is equal to right hand side. So it is proved. We have to get 2 cosec A. Okay. Now question number 3. Question number 3, you have LHS cos theta upon 1 minus tan theta minus sin square theta by cos theta minus sin theta, and we have to prove that this is equal to cos theta plus sin theta. As you can see, cos theta plus sin theta. So here, now first we change this tan into sin, because everything in terms of sin cos, so tan also we change to sin cos. Okay, so we get cos theta 1 minus sin theta by cos theta minus sin square theta, this as it is you write cos theta minus sin theta equal to. Now if you take LCM, then if you change division multiplication, this cos will go up, so you get cos square theta, and LCM is you get cos theta minus sin theta. If you remember, if you take LCM, this will be cos theta minus sin theta, and this cos theta goes up, becomes cos square theta minus sin square theta upon cos theta minus sin theta. Okay, so here, because you have the same expression in both the denominators, so LCM also will be same. So if you take LCM, LCM is cos theta minus sin theta. So you have cos square theta minus sin square theta. Okay, because LCM is same as denominator, so numerator won't change. So this is in the form of a square minus b square. So we can write this as cos theta plus sin theta into cos theta minus sin theta. Okay, upon cos theta minus sin theta. So this cos theta minus sin theta cancel. So what is left? Cos theta plus sin theta, and that is equal to right hand side. So it is true. All right. Now question number 4. Number 4, LHS. So it is cosec to the power 4 theta minus cosec square theta equal to cot to the power 4 theta and plus cot square theta. So we have to change cosec into cot. Now this formula, the cosec square you can change into cot. So cosec square is 1 plus cot square. So here cos e to the power 4 is there, so we take cosec square theta common. So cosec square theta common, so we get cosec square theta minus 1 you get. Okay. So cosec square theta equal to 1 plus tan square theta. Okay. And cosec square theta, because 1 plus cot square theta this is. Okay. So 1 plus cot square theta equal to cosec square theta. This is the formula. So 1 cosec square theta is 1 plus cot square theta, because there is only cot. And if you take 1 this side, cosec square theta minus 1 will be cot square theta. So this will be equal to cot square theta. Okay. So if you multiply, cot square into 1 will be cot square theta, and cot square into cot square will be cot to the power 4 theta. Okay. So we got RHS. It is cot to the power 4 theta plus cot square is the same thing. Okay. That is number 4. Now, question number 5. This is ICSE question. Question number 5. This is ICSE. Year is 2013. Okay. So LHS, it is 1 minus cos A, 1 plus cos A root over. Okay. So this is equal to, now you see there are two types of problems like this. Here 1 plus cos A, denominator is 1 plus cos A. Other one is here in terms of tan and sec. Okay, since 1 plus cos A is there in the RHS, so what we do, we multiply both numerator and denominator by root over 1 plus cos A. Okay, so what we get here, 1 minus cos A, 1 plus cos A root over into, we multiply by 1 plus cos A under root 1 plus cos A. Okay, if it is 1 plus cos A is not there, then we have to multiply by the opposite sign. If it is 1 plus cos A, we have to multiply by 1 minus cos A. That's what we do in the next term. But since 1 plus cos A is there in the RHS, so we multiply by 1 plus cos A. So here 1 A plus B must be formula. So you get 1 minus cos square A, and here 1 plus cos A is 1 plus cos A and its whole square. You have to know the difference. Okay, here plus minus, so A plus B must be formula used. Here same thing, 1 plus cos, 1 plus cos. So this will be whole square. So 1 minus cos square A is sin square A, and 1 plus cos A and its whole square root under. So to cancel root, we write this in terms of 1 whole square. So we can write this as sin A upon 1 plus cos A and its whole square and under root. This square will cancel root, so what we get, sin A upon 1 plus cos A equal to RHS. So it is root. Okay, so you have to be careful here. Now, question number 6. Similar question, but RHS is given in different form. Question number 6. 1 plus sin A upon 1 minus sin A root over. Okay, so we have to get tan A plus sec A. So in this case, we multiply by opposite sign here. Okay, in the denominator. So we write this as 1 plus sin A upon 1 minus sin A into, now we multiply by opposite sign, 1 plus sin A, 1 plus sin A here, root over. This will give you here 1 plus sin A into 1 plus sin A is 1 plus sin A whole square as in the previous sum, and here A plus B minus B, so 1 minus sin square A. We are using A square minus B square formula. So 1 plus sin A upon 1 minus sin square A is cos square A and its whole square. So we write within 1 whole square, 1 plus sin A by cos A and its whole square, and this, so this will cancel here, so we get 1 plus sin A by cos A. So but there are two terms, so we separate, 1 by cos A plus sin A by cos A. If there are two terms, then you have to separate here. So 1 by cos A is sec A, and sin A by cos A is tan A. So we got sec A plus tan A, or tan A plus sec A is the same thing. So RHS. So it is proved. Okay, next question is also similar in terms of sec given. Okay, so there are two expressions under root. Question number 7, LHS. So we have sec A minus 1 by sec A plus 1 root over plus sec A plus 1 by sec A minus 1 it should be. Okay, sec A minus 1 it should be equal to 2 cos sec A. So you have to get 2 cos sec A. So here also we follow the same process. We multiply by opposite sign here. So we get sec A minus 1 by sec A plus 1. So you multiply by sec A minus 1 here, opposite sign. Here also sec A minus 1. Plus here also with the same thing. Sec A plus 1 and sec A minus 1 should multiply by sec A plus 1. Here also sec A plus 1 with opposite sign we multiply. So here same sign, so we get sec A square, sec A minus 1 whole square, because same sign. Here you get sec square A minus 1 because A plus B, A minus B. Plus here also sec A plus 1 whole square minus, here you get sec square A minus 1 because sec A plus 1, sec A minus 1. So opposite sign. So A plus B, A minus B formula we use. So we get here sec A minus 1 whole square upon sec square A minus 1 is tan square A plus root over here sec A plus 1 whole square upon tan square A. So since here square is square, so square will cancel root. So we get sec A minus 1 by tan A plus sec A plus 1 by tan A. So since you have the same thing in the denominator, so you can take LCM here. It is tan A, so you get sec A minus 1 plus sec A plus 1. So this will give you, okay, this will give you sec not sec A, 1 and 1 get cancelled because minus plus, sec A plus sec A will be 2 sec A by tan A. So now you can change to sin cos. So you get 2 sec A is into 1 by cos A upon tan is sin A by cos A. So 2 into 1 by cos A into this sin by cos you can write as cos A by sin A, reciprocal. So cos cancel. So 2 by sin A, so 2, 1 by sin is cosec A is equal to RHS. So it is proved. Okay, now we take the last question. Question number 8. LHS is equal to, we have sec to the power 6A minus tan to the power 6A, and this is equal to, we have 1 plus 3 tan square A plus 3 tan to the power 4A. That's what we have to get. So since power is 6, we can write this as sec square A whole cube minus tan square A and its whole cube. Okay, so that 2 3s are 6, 2 3s are 6 here. So we can use here A cube minus B cube formula, A cube minus B cube, that is A minus B whole cube. Okay, and then we have minus 3AB into A minus B. So this is the formula. Okay, so here sec square A minus tan square A whole cube minus, okay, 3 sec square A tan square A into sec square A minus tan square A. This is using this formula, A minus B whole cube minus 3ab into a minus b. Okay. So but sec square minus tan square is 1. So 1 cube minus 3. Since there is only tan in the RHS, so this sec square you can change to 1 plus tan square a into, you have tan square a and into sec square minus tan square is again 1. So 1 cube is 1 minus, here you get 3 tan square a into 1 plus tan square a. So if you open the bracket, because there is no bracket in the RHS, so 3 tan square into 1 is 3 tan square a, minus into plus is minus, so 3 tan square into tan square is 10 to the power 4 a is equal to RHS. So it is proved. Okay.